Hello everyone. In this section, we will provide a detailed introduction to all the functions of the forestry module in the point cloud processing software FJD Trion Model v.114. First of all, open the forestry point cloud data that needs to be processed. When we select this data in the Objects section, the corresponding functions in the forestry menu will be highlighted. The specific functions of the forestry module are mainly divided into 6 parts. First, pre-processing, primarily used for planning processing to extract ground points. Secondly, segmentation, mainly to perform single tree segmentation on point clouds. Thirdly, tree editing, used to add, delete, or merge incorrectly segmented trees. Fourthly, calculation and analysis, mainly used for single tree property analysis, storage capacity, and species identification. Fifthly, application, generate a tree report based on data analysis. Lastly, display settings. Next, we will demonstrate the operation of each function using this data. After obtaining forestry point cloud data, the first step is to extract ground points. Clicking on Extract Ground Point will display 3 adjustable parameters in a pop-up window. When we select one of them, the software will provide an explanation of the parameter's meaning in the lower left corner, as well as the range to be set and its effects. So everyone can refer to the explanation in the lower left corner according to different data situations and set the corresponding parameters. After ground point extraction, we will find that the point cloud data between trees and ground has been separated. Next, we need to perform single tree segmentation on this newly generated point cloud. The segment by tree function also has 2 adjustable parameters, and the meaning of each parameter can be understood and set through the explanation in the lower left corner. If the scan trees are large or there are many points, we can increase this parameter, which represents the space between point clouds. After confirming that there are no issues, we can click OK. After the calculation is complete, we obtain the point cloud with completed single tree segmentation. In the drop-down menu here, you will find that each tree has been individually extracted. At this point, the point cloud may still contain some misclassified data. We can correct these errors by adding, merging, or deleting trees in the editing box. Taking this data as an example, we can see that the point cloud of a street lamp is incorrectly counted in the tree at this position. We select this error data, and the point cloud file corresponding to this data will be defined in the Objects menu. Hold down the Control key to select all 4 wrong street lamp points. We need to delete the wrong ones that do not belong to the tree class. After clicking Delete Tree to enter the deletion toolbar, we also hold down Control and select the 4 pieces of data at the same time. Click Delete and confirm. Then we deleted the wrong data. After deletion, click Close. Now we check the point cloud again. We will find that the point cloud mistakenly identified as trees has been removed. Of course, adding or merging is done in the same way. Let's take this tree as an example. When we deleted the streetlight just now, we accidentally deleted the part of the point cloud that belongs to the tree. Now we can first find the ID of this tree, which is number 38. Holding Control to select the unclassified points. After selecting these 2 point clouds at the same time, click Add Tree. We now need to transfer the missing part of the tree crown point cloud from the unclassified point cloud to this tree's point cloud. Click Add Tree and choose between Add Automatically and Add Manually. Here we choose Add Manually. At this time, the missing tree and unclassified point clouds will be displayed simultaneously. Rotate to an appropriate view angle and use the Selection tool to select the unclassified point cloud parts. After selection, add it as a single tree. Later, we can merge the 2 single trees into 1 tree. Click OK. Now, under the Objects menu, a new tree has been generated, which is the point cloud data for this part. Then click Exit. We select the original tree 38 and the newly generated missing part point cloud simultaneously to merge these 2 point clouds. Click Merge Tree. Holding down the Control key, select the 2 point clouds and click Merge. Now a complete tree point cloud has been merged. If we go back to check the unclassified point cloud, we will find that this part has been added to the point cloud segmented as a single tree. The above mainly demonstrates the functions of delete tree, add tree, and merge tree. Next is the calculation and analysis of trees. The first is to separately distinguish the tree crown and trunk. There are 3 adjustable accuracies: low, medium, and high. Let's take medium accuracy as an example to classify the trunk and crown. A prompt will pop up after completion. Now in the display window, we can see the separately selectable trunk and crown. And we can also choose to display the tree ID, which is the corresponding number for each tree. The second function is property calculation based on the single trees. Each tree includes coordinates, tree height, diameter at breast height, dBH, crown width, and other data. We can select the corresponding data as needed. After selection, we can separately calculate the properties of each tree. It also has the function of setting. The setting function is according to different requirements, such as setting the height range for crown or truncation, which can be customized here. After the calculation is completed, the report function will be activated. Now we can check the coordinate information of each tree and the selected properties through the report function. We can also perform conditional filtering. For example, if we only need trees taller than 10 meters, only the filtered data will be displayed. Of course, we can also add additional filtering conditions, such as dBH greater than or equal to 0.15 meters. At this time, another round of filtering will be performed. Enter the corresponding information and save path in the export settings. Then we can export the report. The next function is the storage capacity. Usually, in the collection process, most of the time we deal with forestry plots. The actual forestry area may be much larger than the sampling area of our plots. Therefore, it is necessary to infer the total volume of the whole forest based on the storage capacity of the sample plots. Select the corresponding country, tree species, and calculation method. The stand area refers to the total area of the overall plot. Assume it is 10,000 square meters. The standard land area refers to the area of the scanned plot currently being calculated. Click OK after entering. Now we get the stand volume of the overall plot, the standard land volume of the scanned plot, and the volume of trees per hectare. Finally, the last function is species identification. We can add the video data taken during scanning and use it to identify and name the tree species corresponding to each tree based on the video. Load the corresponding MP4 format data, and also load the FJD data generated after the point cloud is calculated. Then, perform image linkage calculation. After completion, we can see that the point cloud and image are displayed in split screen mode. Now we can use the image icon to control the area to go and label the tree species. Take tree number 6 as an example. After selecting tree number 6, the tree ID will be identified in the upper right corner. Then select the tree species from the drop-down menu and click OK. Now, the tree species of tree number 6 will be marked. Next, select tree number 8. We can continue to move the view forward to confirm the correspondence between the point cloud and the image. Select the tree ID and the tree species and then confirm. After marking is completed, click Exit. The marked trees will be highlighted. In the export report, the species of these trees will be identified. The above is the introduction of functions in the forestry module of the FJD Trion Model v.114. Thank you for your attention.